Hey everybody, this is Larry. This is day 8 of the Leetcode Day Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this one. Today I feel great. I don't know why. Maybe I just slept a lot. But I just came back from a 11-mile run. 10 miles easy and another mile. Just trying to get used to being faster. So we'll see. Yeah, we'll see how that goes. Maybe I need to start or I don't need to, but maybe I should start a running training vlog. I don't know. Let me know in the comments. Training for the marathon later this year. But anyway, all right, let's take a look at today's problem. Hope everyone's having a great weekend. It is Sunday here. Maybe it's Monday by the time you watch this. But hope everyone had a good weekend and hope everyone's week coming up will be good. And today we have 1823. Find the winner of a circular game. And also we have the weekly premium problem. So definitely stay tuned for that. Alright, so and friends playing a game, moving clockwise, count the next K, the last to lose the game, then immediately. Okay, so I mean I think this is like is like the Josephine problem, right? But linear time with constant space. Yeah, I mean, what I was going to say is that you can obviously simulate this. I think simulating this with a queue or something like this is not that bad, right? Maybe it's like n square or something like this in the worst case, I think. The logic being that and the complexity just off my head, right? And the logic for that complexity is just that in the worst case, you remove one person per loop, and you know k mod n. Hopefully this time, you know, when in one, you remove each one loop, and then it takes n for the first one and n minus 1 for the second loop, third and that'd be n squared. So, okay, so that would be fast enough, of course, but that would also not be linear time and constant space. How would I do it with constant space? That's interesting. I'm just trying to think right now how to do it in constant space, to be honest. I don't know that I know. Maybe there's a pattern, right? Well, okay. Let's play around with this, maybe. I mean, yeah, to get it faster than simulation, you know, you have to kind of, I mean, it's almost a given that you have to find a pattern of sorts. And also linear time is wrong, by the way. There's no... Well, I mean, maybe there is, but it's but they're probably just wrong about the linear time because linear time does not mean O of n, or at least not this n, right? The n that is in analysis O of n is the size of the input. The size of the input is not the number n. The size of the input is the number of bits representing the number n. So there's no linear time solution. Oh, well, okay. I mean, there may be a linear time solution if there was like a formula. That would be a linear time solution because that would be on the order of the number of bits, right? Because, you know, for example, addition is linear in that case because adding two numbers of b bits is going to be O of b, and that's the size of the input or something like this. So just to be clear, yeah, I mean, you could say this is O of n for this n, but that is not the size of the input. So you cannot say that, you know, in a weird way, O of small n is not equal to O of n, kind of. I mean, even if this was a big n, you know, they just mean different things, right? So you cannot say that this is linear. So I know that this is a little bit of a rant, but maybe it's a little bit pedantic. But this kind of confusion is how people, you know, I think the most famous example is factorization, right? That's why factorization is not linear time, right? Quote unquote, because you can't just count from 1 to n and factorize it, because that's the n here is still the number of bits, right? So yeah. Anyway, linguistics aside, I mean, that said, I get what they're trying to do. So maybe they just mean like, O of n, which we can try to figure out. Anyway, we should still try to figure out a pattern, right? How does this work, right? So okay, so let's say we have 5 and 2, which is example 1. So 1, 2, 3, 4, 5. The first iteration, we get rid of all the things, right? But then so okay, maybe I'm trying to see if maybe there's a way I can figure out the pattern, right? So 1, we have a 2, 3, 4, 5, 1, 3, 5, and then just 3, right? I mean, I do get that, you can kind of write it like this, but I'm not. I mean, even if you write it like this, obviously, this is not linear, right? Or O of n, rather. But the way to think of, maybe I could think about it as like a recursion, right? Maybe that's the way to do it, because that and when I say recursion, I don't mean like you have to implement it recursively, but I just meant the recursive, the definition of recursion, where it means rewrite the problem in terms of itself, right? And one way to do that, of course, is that, okay, so let's say we have 5 and 2. Now we're trying to think about k, right? So that means that we get rid of this. And then now we have 3, 4, 5, and 1, right? So these are the new numbers. And 1, we can say maybe it's a 6. So that means that, in the sense that, I mean, like 6 mod 5, which is n, is going to give you the answer, but or like the thing, but that's basically the idea, right? So that means that now you add 2 to all the numbers, and then this is just, if you rewrite it, then it's just 1, 2, 3, 4 plus 2 or something, right? To get this, because we already eliminated 2. So then in a way, if you have, you have 5 and 2, that is the same answer as, you have 4 numbers left, still 2, that can change, plus 2, right? And then now we have 1, 2, 3, 4. We'll keep the plus 2 later, right? And then, and then we take the second number. So now it's going to be 3, 4, 1, which, loops around. Let's just say it's 5. So this is again plus 2, right? But now, this is 1, 2, 3 plus 2. So then this is just 3 numbers, 2 plus 2. And then after that, it's going to be 2 numbers. Yeah, just 2 plus. And then you have 1 number left. Well, I mean, 1 number. So then now, what is this number? This is just 3 plus 2, so this should be, is that even right? Is this a plus 2? Maybe I messed this up. Okay, let's actually write it out, right? So here, so then now we have, this is 3, 2, and then now we eliminate the second number. Maybe, I think some part of it is that I'm confusing myself because I'm using 1 index. And I think even though this is how the problem is framed, I think some problems, especially stuff with mod and stuff like this, it gets very confusing with, at least for me, with that. So here, okay, so because we can just add one later, but zero index I think is more intuitive and more natural for a lot of things. Could be wrong, I don't know. But yeah, okay, so then now you have 5 numbers. This is 5, 2. You eliminate 1 to get 2, 3, 4, 0. 0, let's just say we add it by n, right? So this is 0, 1, 2, 3, so this is still plus 2. Okay, so I mean, so that doesn't change. And then now here we eliminate the 1, so we have 2, 3, and 0. Again, added by n. So then now this is 0, 1, 2, and then plus 2, right? And then now we eliminate the 1. We have 2, 0, which is this is 3, and this is now 0, 1 plus 2. And then now we eliminate the 1, so we have the 0 number. I guess this is 2. Because 0 wraps around, so yeah, I mean, I think you need a plus 2 on this, because I don't know. And then now you have 8, right? 8 mod 5. Is that right? I mean, I know that this e goes to 3, but remember that we're in 0 index, so it doesn't make sense, right? Okay. Well, let's work backwards and construct this instead of just adding it naively. Maybe I messed that up there, right? Is that also, I don't know, this feels very weird, to be honest. I know I'm a little bit slow, sorry friends. Maybe there's a easy, I mean, the easy way is simulation, so assuming that you're not here to watch Larry do some for loops. But okay, I mean, this still would be some for loops. Okay, so then now let's bring it back. So the last number is going to be 0 plus 2, because this is the 2. The way I write this is very confusing, to be honest, also. Because then now you remove the 1, so it's going to be 2, 3, 4, 0, right? Plus 2, so now you have 2, 3, 0. Now you have 2, you have 0, 1, 2, so then now you have 2, 0, and then now maybe that's where I got confused, because actually you removed the 0. Well, this is 0, and this is this 0? This is, okay, so this is 0, 1, 2. So then you remove 1, and then this is 0, 2. Or 2, 0. Okay, that's still actually right. Though you wrap this around, this is a 4, that's why it's a little bit confusing. But then now you remove this 0. So then now, well, this is a 0. If you re-index this, this is 0, 1. And you remove the 1, so this is 0. Okay. Then the answer is going to be 0 plus 2. And this is just 8, right? I don't get it. 8 mod 5. Is this a plus 2? I think this is where I'm a little bit confused. I think that's why, to be honest. maybe. Okay, so this is, I think the base case I'm a little bit unclear on. I think that's where I'm a little bit confused. Because this is technically, yes, 2, 0. We re-index this to be 0. So we minus 2, so this is -2, mod 2, so this is 1, right? And then now we remove the 1, so then now we have 0, but there's no +2 here because you only have one number left. And also, yeah, so it's just +6. I think that's where I got confused. Okay, so +6 mod, so it's going to be 0. Yeah, +6, 6 mod 5 is going to be just 1, and which is also wrong, which is why I'm a little bit confused. Well, I mean, I'm confused because it's wrong. Because it's 0 + 6. Is the mod 5 wrong? No, it shouldn't be. So this is 5, 2. This is 4, 4, 2 + 2. This is 3, 2 + 4. This is 2, 2 + 6. This is 1, 2, which gives you 0. So then this is just, well, technically the +6 is here because it's recursive. Well, I mean, now it's just this +2, this is +2. But this is 0, so then now this is 0 + 2, so this is 2, 4, 6, right? So why is this 6? And not 3? So, okay, so this would be 2, 3, 4, 0, I guess in real terms. And now you remove the 3. You remove the 3, so this is 4, 0, 2 in real terms. So far so good, this is everything +2. And then now you remove the 0 in real terms, so then this is 2, 4, and +6. Is this still right? 2, 4, so this is this +6. Is this +6? Maybe this is where I got it wrong. So this is, I don't know what the 230 means anymore. I guess I do, but this is just because this is you have this 402. You remove the second number, so it's gonna be 2, 4. So this is this +6. That's wrong. Maybe I just put in the wrong things here. Man, I thought I wasn't tired, but maybe my brain is still just not functioning. I'm getting confused now. So okay, so you have 4 numbers. So this is now 0, 1, 2, 3, which is +2. Okay, right? So this is the mapping, and then you remove this, so you have 2, 3, 0, and this is +2, which makes which is correct since this is the real term one. And then now this is 0, 1, 2, right? Remember that this is mod 4 now. Oh, I see. It's not mod 6. That's where the difference is. Okay. That's where I got confused. So this is plus mod 5. This is mod 4. This is mod 3. The other thing I was wondering was why this was so yeah, okay. Because the other thing that I was wondering was why yeah, like you could have because the closed form would be very easy in that case, but now I see what happened here. Okay. I mean, I think now this is pretty okay, right? Man, I mean, I had the idea, but I just couldn't wrap my head around it. Sometimes, you know, this is why I will also say, you know, I always talk about, you know, people ask me what can they do, you know, like 2 days before an interview or something like this. And that's why I always say, eat well, sleep well, rest well, right? Because if you don't, this is what happens. You know, even when you have the right idea, I just didn't put it together, right? So okay, so this is, I think this number is wrong, but oh no, this is mod 4, right? I don't know what this number represents anymore. But then this is this mod 3. So yeah. So this is this plus. Oh no, but this 2, 4 is after modding 4 and 5. So this doesn't relate to this directly anymore. But okay. So I mean, I think we have the pattern now, right? I mean, if you want to write it recursively, I'll start writing recursively, but of course that's not going to be constant space, even in their weird definition of the word. But let's actually, you know, get an answer first. And then we'll worry about it in a bit. And of course you can write it with this, but let's write it out. And then I think this is tail recursion, so then we can probably optimize. But yeah, the way that we thought about it is that, okay, if n is equal to 1, if there's one number left, we return 0, because that's just how the indexing goes. Oh, and this is going to be 1 plus this. Maybe we have to mod this, but oh no, this is just a 0 index after modding anyway. Yeah, so then now we return f of, we have a smaller one, we have k, right? We have plus k, but now we want to mod it by n, right? Okay. Apparently I've done it before. Okay, not gonna look at it. Because they did it with the for loop. Because I want to do it myself. That's why. So okay, so you know, so this works. It's a for loop. It is, you know, just the way to do it. And you kind of saw how I did it, even though it was very slowly, but it was very deliberately, and just kind of just go through it, right? And you saw where I made the mistake of keeping the same mod, even though that didn't make sense. In retrospect, it didn't make sense, and of course, things that you know are wrong doesn't make sense afterwards. So, you know, it always looks easier looking back. But I think I was just trying too hard to find an elegant solution. But in any case, but yeah, this is going to be O of n time, O of n space, not linear time, not linear space, just O of n for this n, right? But yeah, but you know, like I said, you can see that this is tail recursion, so we could probably for loop this out. How do we want to do it? So yeah, I mean, I think this is pretty straightforward actually. Yeah, so for I mean, and you could kind of think about it as reverse DP. That's how I'm trying to think about it. In range of n, maybe 1 n, right? So then now, well, we still have 2, because for 1, maybe the answer is just going to be 0, which is the base case. And then now for I, with I n is 2, then f is just equal to the previous f plus k mod I, right? And then that should be it. Is it that? Nope. Did I mess up? I mean, I clearly did, but plus k. So if I is 2, I'm just trying to unroll this loop in my head, right? Because, and then just do it backwards. I meant to write this, but I just forgot. Okay, yeah. Because I was thinking this loop, and then I just forgot. I am just very sloppy. I don't know why. All right. Yeah, I mean, this is basically just this thing written backwards. So yeah. Yeah, I mean, this is, O of n time, I guess, constant-ish space. This is actually linear space, if you want to think of it that way. But yeah, that's all I have for this one. Let me know what you think. Thanks for watching. This was a little bit long, but I think at the end we were able to get it. Yeah. Let me know what you think. Let me know how you came about this. I don't know that I don't think I explained this per se, but I did show you my thought process. So if you watched all of it, hopefully that made sense. It's just, as I said, the key observation is thinking about, expressing the problem in terms of itself. I think, I think we do talk about speed a lot. As you can see, practice will give me that speed. But if you actually learn it, if you actually learn how to problem solve, you could figure these out. It's just, it may take a little bit of time in my case. So, but yeah, that's all I have for this one. I'll do the weekly problem next, so watch out for that. And thanks for watching. Have a great week, everybody. Stay good, stay healthy, to good mental health. I'll see you all later and take care. Bye-bye.